All right, so this is how we would run a small molecule on our mass spectrometer, okay? So we have here a syringe pump, and the syringe pump, you put your sample into this syringe right here. This blue tube right here, and this syringe pump we have, it's stored in this drawer over here. HPLC accessories, usually we put it right here. Now, there's nothing wrong with everybody using it, but we have to make sure it's clean every time it's being used. Obviously, the person who comes can also verify that it's clean before they do anything. This is also the syringe pump that we use for our standards, so we want to keep it free. I mean, we can always buy a new one, but we want to keep it as clean as possible. All right, so the first thing you're going to do is you're going to fill this up with your solution, right? And again, you're only going to need, you're only going to need about, let's see, well, it depends on how long you want to run the sample, but 100 microliters is probably more than plenty. So I'm getting out some air bubbles there. All right, now, this tube right here goes with the syringe pump. This tube goes right here with the syringe pump, or with the syringe. And then this tube right here that comes from the column, this brown one here, this one is for using the HPLC to load and elute off your samples. So for a small molecule, we're just going to be using the syringe pump. Okay? Now, when you put this in, I have some black marks here on this, and you want to make sure all of those stay exactly how they are. So you're going to have to unscrew this if the HPLC side is plugged in. You're going to want to unscrew it. Oops, you're going to have to unscrew it and put the blue side in. And that, you want to make sure you don't touch this housing right here, any of this metal. It builds up a static charge sometimes. If it's off, if nothing's running here, then it won't shock you, but sometimes it'll shock you if you touch some of this metallic stuff right here. So it's nothing terrible. It happens to me all the time, but it's not enjoyable. All right, so then this here, we're going to put onto our syringe. Okay, and then we'll put it into our syringe pump, and we'll push it down, and then get it going there. So we can feel the screw drive here, make sure that it's moving, and that it's feeding there. Okay, and we'll just do that for a little bit before we turn it on to kind of make sure we purge anything that's in the line, so it's ready to go when we start. All right, so there's no log in here. You just turn this, click there, and then we're after the tune window. So you go here to the tune window, and this is what the tune window looks like. Now this is the most important part here, so you don't mess up anything for other people's experiments, is you have to go here to File and open up Small Molecule. So once you do that, then whatever changes you might make will be associated with this tune file, Small Molecule, and not somebody else's tune file. All right, so we have Small Molecule here, and what we're going to do with Small Molecule is we have this on. We can also control the pump here by this little icon there. So we can click right here, and we can see right now it's running at 5 microliters per minute. That's for a 500 microliter syringe, so we can make sure that we recognize that it's appropriate number here, so you can change it to whatever syringe size you wanted. We have it on. We can turn it off here, push apply, and that'll turn it off. So we can put it back on again. Okay, so we have a way to control the syringe here. All right, and then when we're ready, we can just turn on like that, and we'll see that it starts running. This shows us that the mass spec is collecting, and then here we can see a couple of peaks. If we want to adjust our range, we can click on this little box right there and change the range. So if I want to go higher to maybe 800 or even higher, right? So I put on 800 there, say apply, say okay. So right now I have 3 chemicals in here. One that's about 353, one's about 204, and one's about 150. So this 150 is acetaminophen. This, let me see if my compounds are No, they took the compounds back, but... So if you want to run a standard... Oops. We lost a little bit of pressure. A little bit of pressure. It wasn't pushing all the way, so we got it pushing now. Oh, another thing I didn't mention here, that you could change the flow rate. So instead of 5 microliters per minute, we could go up to 10 or whatever. You know, we can go as low as 1. And for this setting, we probably get plenty of signal, okay? Now, there's other ways to further kind of identify what compounds we're looking at. Let's say I'm just interested in this 150 here, which is acetaminophen. And let's see, I can bring up the structure for acetaminophen. All right, so there's our structure for acetaminophen. And let's say that I wanted to further fragment that acetaminophen. I could go right here and maybe make my range from, I don't know how low it can go here. Let me see, put in 50, see how low it can go. So I can go down to 50. I don't know if I can go lower. So 50 is the lowest it goes, it looks like. Okay, so here we have 50, and maybe I want to have the high just 180. There we go. So now we have our acetaminophen here. Now, if it's a little bit too jittery for you, you can change how long the samples are being taken, or you can hold onto this button right here, and it'll kind of sum up multiple runs, kind of stabilize the peaks a little bit for you. Okay. All right. So if I want to fragment this 150, now there's probably a degree of fragmentation that's occurring. I can increase the fragmentation by turning this fragmentation value up to a higher value. So right now it's at 35. If I put it down to 0, for example, or it's best, I guess, just to turn it off and say apply, then I see a lot fewer peaks that appear below the 150 here, okay? So all of these are probably fragmentation peaks to some extent. But if I want to further fragment the molecule to try to learn more about it, then I can turn fragmentation energy on, and if I start off with something like 10 and say apply, and then I bump it up to something like 25, apply, and then I can see more peaks showing up. Whoops, that's too much. Or maybe I need a little bit of higher flow now because I'm fragmenting on my compound. So I'll put this up to 5, the flow rate up to 5. Oh, I had another air bubble in there. I don't know. I had some air bubbles to start off with. I guess that was my issue. All right. So let's go back here to the fragmentation energy. Let's bring it up to like 60. And then we can start seeing some greater peaks like 68 and 106 coming from the 150. Now, if you get too high, right, then eventually the 150 peak begins to disappear and you get lots and lots of fragments. So you can control the fragmentation you want to get, kind of monitoring the 150 peak here as your base peak. So that's how that works. I'll bring this back to, let's see. There we go. And then I'm getting a lot more peaks now because I have my fragmentation on higher. So if I turn my fragmentation, well, I can just turn it off. Then it's going to give me my my peaks. Now I don't know what this 704 is, or these ones down here, I guess. But they could be dimers. Let me see. Are these dimers? I don't know. Anyway, I think that this should work okay. Now again, you'll want to make sure that before you run it, you have run through a sample of a blank. Make sure that you get rid of any background peaks or anything to start off with. All right. So you can see that after I turn off this syringe pump, or pull this back, then it takes a little bit of time for the sample to stop collecting. So it's pretty sensitive, but it'll eventually stop. You can see here, this option right here fixes this intensity. The intensity generally kind of averages out. Oh, if I turn off the average as well, then it'll start becoming lower and lower. All right. And then you just want to make sure you turn it off, clicking that button there, and then that's it. Now, I've never dealt with trying to save these. If you push save here, it's referring to the method. So actually printing this up or something like that, I'm not sure the best way to do that. So you'll have to look into this. Save graph data right there, I guess. But I don't know how to get into that. Anyway, that's probably sufficient for now.